direct form 2 realization. Realize. Now for this system we have to realize a circuit using the direct form 2. So we have already learned about the direct form 2 realization with expression and what is the final structure. So same procedure we will follow for problem solving in the direct form 2. Given expression, write the given expression and give it as equation number 1. Now apply Z transformation on both sides. So whenever we are applying the Z transformation on both sides, then y of n becomes y of z. Y of n minus 1, the delay is minus 1. Z power minus 1 into y of z. If it is y of n minus 3, then z power minus 3 into y of z. Similarly, if you are applying the Z transformation on x of n becomes x of z, then x of n minus 1, it becomes z power minus 1 into x of z, and if it is x of n minus 2, z power minus 2 into x of z. Now substitute all those things in the equation number 1. Therefore, after substituting the above expressions, we have y of n becomes y of z is equals to minus 3 by 8 z power minus 1 into y of z plus 3 by 32 z power minus 2 into y of z plus 1 by 64. So all these are constant. So whenever we are applying the Z transformation on constant, it will not at all change. The constant will be constant throughout the problem. Then plus x of z, then plus 3 into z power minus 1 into x of z, plus 2 into z power minus 2 into x of z. Now take y of z as a common, those the term which are having the y of z. So this is the first term, we have a y of z 1. Take all these y of z terms to the left hand side. Then you will have plus 3 by 8 z power minus 1 minus 3 by 32 z power minus 2 minus 1 by 64 z power minus 3. Similarly, here I am taking as x of z as a common. So why I am taking the common factor? Because I need to get the transfer function, right? H of z is equals to y of z by x of z. So for that purpose, I am taking a common factor in y of z as well as x of z. So that I will get one polynomial function with a numerator and denominator, right? If I take x of z as a common, 1 plus 3 z power minus 1 plus 2 z power minus 2. Now take this to the RHS side and this x of z to the LHS side. Therefore, 1 plus 3 z power minus 1 plus 2 z power minus 2 divided by 1 plus 3 by 8 z power minus 1 minus 3 by 32 z power minus 2 minus 1 by 64 z power minus 3. Now I am considering one intermediate stage, that is w of z. Multiply and divide by w of z on the LHS side. Y of z by w of z into w of z by x of z. So remember, always equate this value to numerator and this factor to denominator. Equate with the numerator value and equate this value with the denominator value, so that you will get the proper direct form to realization structure. Now equate the numerator value with y of z by w of z is equals to 1 plus 3 into z power minus 1 plus 2 into z power minus 2 divided by 1. Now cross multiply to get the standard format, that is y of z is equals to w of z multiplied by 1, that is w of z, plus 3 into z z power minus 1 into w of z plus 2 into z power minus 2 into w of z. Now apply the inverse z transform on both sides. Then y of z becomes y of n in time domain. Then w of z becomes w of n plus 3 into this z power minus 1 into w of z becomes w of n minus 1 plus 2 into w of n minus 2. Give it as equation number 2. Now I am designing for the realization for this structure. Equation number 2. What is the input here? W of n is the input and output is y of n. What is the coefficient for w of n? The coefficient is 1. Then first it is delayed by one sample, that is w of n minus 1. What is the coefficient for w of n minus 1? 3 is the coefficient. Then to get w of n minus 2, again it is delayed by one sample, that is w of n minus 2. So the coefficient is 2. If you are identifying this expression, this contains how many adders? 2 adders. Okay. So connect this term with the adder circuit, then again connect with the adder. So therefore this is our realization for the expression equation number 2. Now equate the denominator factor, that is w of z by x of z, with the denominator factor as 1 by 1 plus 3 by 8 z power minus 1 minus 3 by 32 z power minus 2 minus 1 by 64 z power minus 3. Now again cross multiply and apply the inverse z transformation. So w of z is equal to x of z multiplied by this, right? X of z is equals to w of z plus 3 by 8 z power minus 1 into w of z minus 3 by 32 z power minus 2 into w of z minus 1 by 64 z power minus 3 w of z. Again apply inverse z transform on both sides. Then x of z becomes x of n, w of z becomes w of n plus 3 by 8 w of n minus 1 minus 3 by 32 w of n minus 2 minus 1 by 64 w of n minus 3. Remember, always output we have to equate it to input, right? So here output is w of n, therefore w of n, and take all these values to the RHS side. Then you will have x of n minus 3 by 8 w of n minus 1 plus 3 by 32 w of n minus 2. All the positive coefficient becomes negative, negative coefficients become the positive if you are going to either left hand side or right hand side, opposite side, plus 1 by 64 w of n minus 3. So this is our final equation number 3. Now again we are realizing the circuit for the equation number 3, and at last we will match both the circuits in a single structure. For equation number 3, if you are drawing the structure, then w of n, so input is x of n and w of n is the output. First x of n coefficient is 1. Now in the same expression we have the delay element for w of n, so z power minus 1 w of n minus 1, and what is the coefficient for w of n minus 1? Minus 3 by 8. Then again one more delay element to produce w of n minus 2, and the coefficient is 3 by 32 and last W of n minus 3 coefficient is 1 by 64. Now all are added by adder circuits. So this is our final structure for equation number 3. So individual structures has to be drawn. Later combined structure, that is our direct form to realization. The overall structure is, we have the combined form for this W of n minus 2. The structure is 2, 3, 1. Final overall output, that is W of n. So why we don't have a connection with this, with output? Because in the given difference equation there is no connection with this particular W of n minus 3 with the output. Suppose in the given connection W of n minus 4 is there, then you have to make accordingly and connect it to output. So all these structures will depend on the given difference equations. For this given transfer function, direct form 1 and direct form 2 realization structures we have to draw. Solution. First write down given h of z is equal to, give it as equation number 1. Now in the previous problems we have in terms of n domain, but this problem added with z cube, right? It is not in terms of z power minus also, right? Now if you are identifying this, you have z cube. In denominator, if you are multiplying z with z square, what is the highest polynomial? Z cube again, right? So I am taking z cube as a common in the numerator as well as the denominator factor. So 8 minus 4 z power minus 1 plus 11 z power minus 2 z power minus 3 if I take z cube as a common. Next, here I am taking z as a common, from here I am taking z square as a common. 1 minus 1 by 4 z power minus 1, and second factor becomes 1 minus z power minus 1 plus 1 by 2 z power minus 2, right? Now z cube and z cube will get cancelled. Therefore I have a factor as 8 minus 4 z power minus 1 plus 11 z power minus 2 z power minus 3. Now multiply this with this factor. Then 1 minus z power minus 1 plus 1 by 2 z power minus 2. Now multiply minus 1 by 4 with all these particular terms. Then minus 1 by 4 z power minus 1. So minus and minus becomes plus 1 by 4 z power minus 2 minus 1 by 8 z power minus 3. Now add the common terms, that is z power minus 1 minus 1 by 4 z power minus 1. 1 by 2 z power minus 2 plus 1 by 4 z power minus 2. Multiply the y of z with the numerator, cross multiply on both sides. You will get the difference equation in terms of z domain. Apply the inverse z transformation on both sides.